Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
This is episode 4 of our 5-part Platform Engineering 2026 Look Forward series. We've covered agentic AI operations, platform engineering going mainstream, and developer experience metrics beyond DORA. Today, we're tackling something that might sound counterintuitive. Why the best thing happening to Kubernetes in 2026 is that it's becoming boring.
And I want to be clear about what boring means here. We're not saying Kubernetes is irrelevant or outdated. We're saying it's reaching a level of maturity where the infrastructure becomes invisible. And for platform teams, that's exactly what you want.
Let me set the stage with some historical context. Think about the Linux kernel. In the early 2000s, there were constant debates about kernel versions, file systems, schedulers. Today, nobody outside of specialized kernel developers thinks about it. Linux became boring, and that's precisely when it conquered the world. It runs everything from smartphones to supercomputers.
The same pattern happened with Postgres. For years, there were endless debates about which database to use. Now, the default answer in many organizations is just use Postgres. It's boring. It works. That's the goal.
Kubernetes is entering this same phase. Look at the recent releases. Kubernetes 1.32, 1.33, 1.34, 1.35. What's the common theme? Incremental stability, small refinements, edge case fixes. There are no paradigm shifts, no fundamental API rewrites, no new concepts to learn.
Kubernetes 1.35, nicknamed Timbernetes, which we covered in detail in episode 62, exemplifies this pattern. The headline features are things like improved leadership handoff observability and incremental scheduling enhancements. Important for operators, sure, but not revolutionary.
And here's the key insight. The last genuinely major change was Sidecar containers going GA in Kubernetes 1.29. That was over a year ago. The core platform has stabilized.
Some folks hear this and get nervous. They worry that Kubernetes is stagnating or being replaced, but that completely misses the point. Innovation isn't dying, it's moving up the stack.
This is where the composition layer renaissance comes in. While Kubernetes core is stabilizing, there's an explosion of innovation in tools that build on top of Kubernetes.
Take Crow, the Kubernetes Resource Orchestrator. This is a Google-backed project that launched in October 2024. It represents what some are calling the Goldilocks approach to Kubernetes abstraction. Not as complex as Crossplane, not as limited as Kustomize. Just right for most platform engineering use cases.
We covered Crow in depth in a recent episode, but the key point is this. Crow lets platform teams define resource groups that compose multiple Kubernetes resources into higher-level abstractions. Developers request a web application, and Crow creates the deployment, service, ingress, horizontal pod autoscaler, and pod disruption budget automatically.
And this is exactly what boring Kubernetes enables. When the core platform is stable and predictable, you can confidently build abstractions on top of it. You don't have to worry about the next release breaking your carefully crafted golden paths.
Let's map out the composition tool landscape as it stands in late 2025. At the simplest end, you have Kustomize. It's mature, stable, and great for simple overlays and environment variations.
Then Helm for package management. Helm 4 is on the horizon, but Helm 3 works fine for most use cases.
In the middle is Crow for resource composition. It's emerging but gaining traction quickly. And at the high complexity end is Crossplane for full control plane capabilities. That's enterprise-focused and requires significant investment to use well.
Now, here's the provocative question we should address. If Kubernetes is becoming invisible, Do developers even need to know it exists?
This is a genuine debate in the community. The Just Use Managed Kubernetes consensus has essentially won. EKS, GKE, AKS handled 90% of operational concerns automatically. Managed control planes, automatic upgrades, integrated security. The remaining 10% is what platform teams abstract away.
So if you're building a platform in 2026, should developers ever touch kubectl?
My take? Developers shouldn't need to know Kubernetes, but they should be able to learn if they want. The platform provides guardrails, not black boxes.
I like that framing. It's the difference between abstraction and obfuscation. Good abstractions hide complexity while remaining inspectable. Bad abstractions hide everything and break mysteriously.
Think about it like the network stack. Most developers don't need to understand TCP to build web applications. They work with HTTP abstractions. But when something goes wrong at the network layer, having engineers who understand the underlying protocols is invaluable.
The same principle applies to Kubernetes. Most developers should interact with platform APIs, git push, and stuff appears. But when there's a production incident, you need people who can drop into kubectl and investigate.
What I find interesting is where innovation is happening. Kubernetes core is boring, but the ecosystem is anything but. Let's walk through the active frontiers. First, AI and ML infrastructure. GPU scheduling, model serving, inference optimization. Projects like K-serve and VLLM are evolving rapidly. The pressure from AI workloads is driving real innovation in how Kubernetes handles specialized hardware.
Second, edge computing. Lightweight Kubernetes distributions like K3s and KubeEdge are maturing. The Kubernetes at the edge story is getting more compelling as organizations deploy to retail stores, factories, and remote locations.
Third, security. Policy as code has reached maturity. Kyverno and OPA Gatekeeper are now table stakes for enterprise deployments. The debate has shifted from should we have policy enforcement to which policies should we enforce by default.
Fourth, observability. OpenTelemetry has consolidated the fragmented observability landscape. The OTEL collector, eBPF-based instrumentation, and standardized trace propagation are now the expected baseline.
And fifth, GitOps. The Argo and Flux ecosystems continue to evolve. Argo CD 2.x and Flux v2 are both mature and feature-rich.
GitOps is no longer an emerging pattern. It's the default deployment model for most platform teams.
The meta point here is that Kubernetes provides the stable foundation. Innovation happens in the layers around it. Platform teams benefit from a boring core with an exciting ecosystem. So what does this mean strategically for platform teams heading into 2026?
First, stop chasing Kubernetes features. Most organizations don't need the bleeding edge. Running N-2, meaning 2 versions behind the latest, gives you stability while staying within the support window.
Second, invest in abstraction. The stable Kubernetes foundation means your investment in golden paths and self-service capabilities won't be obsoleted by the next release.
Third, focus on developer experience. Kubernetes details should become an implementation detail. Measure success by developer outcomes, not Kubernetes mastery.
And fourth, consider the Kubernetes-less developer experience as your North Star. Can your developers deploy without ever thinking about pods, services, or ingress? That's the goal.
Let me give a concrete example. A mature platform in 2026 might work like this. A developer writes code, pushes to a repository, and declares, "I need a web service with a database." The platform handles everything else: resource provisioning, networking, scaling, observability, security policies. The developer never writes a YAML file.
Under the hood, it's all Kubernetes. Deployments, services, horizontal pod autoscalers, network policies, but the developer experience is completely abstracted.
And here's the beautiful part. When something goes wrong, the platform engineer can still drop into kubectl and debug. The abstraction doesn't hide the underlying system, it just removes it from the happy path.
Let's talk about the managed Kubernetes maturity curve, because this is where the boring thesis really proves itself.
In 2025, the cloud provider Kubernetes offerings are essentially commoditized. EKS, GKE, AKS all do roughly the same things.
automatic upgrades, managed control planes, integrated identity, built-in observability. The differentiation between providers is minimal at the Kubernetes layer.
Which means competitive advantage has moved up the stack. It's not about which managed Kubernetes you run, it's about what you build on top of it.
This is exactly why platform engineering matters. The infrastructure layer is commodity. The developer experience layer is differentiation.
And most enterprises are running multiple Kubernetes clusters anyway, 2 to 3 at minimum across different regions or clouds. The abstraction layers like Crossplane and Crow help manage this multi-cluster reality.
Let's make some predictions for Kubernetes in 2026.
Prediction 1. Kubernetes 1.36, 1.37, and 1.38 will all be boring releases. Incremental, stability-focused, with no major new concepts. And that's a good thing.
Prediction 2, Crow or something like it becomes mainstream. The Goldilocks approach to composition will win adoption because it's simpler than Crossplane, but more powerful than raw customize.
Prediction 3, Kubernetes certified becomes table stakes, like being cloud certified. It becomes an expected baseline for platform and infrastructure roles rather than a differentiator.
Prediction 4, AI workloads drive the remaining innovation in Kubernetes core. GPU scheduling, device plugins, and inference serving are the frontiers where the Kubernetes community is still actively innovating.
And prediction 5, platform maturity gets measured by Kubernetes invisibility. The question shifts from how well do your developers know Kubernetes to how little do they need to know.
That last one is the key metric. If your developers are still writing Helm charts and debugging YAML indentation, your platform has work to do. If they're pushing code and watching it deploy automatically, you've achieved the goal.
Let me close with the boring infrastructure thesis stated plainly. Technology follows a predictable maturity curve. It starts exciting, full of new ideas and constant change. It becomes useful as patterns emerge and adoption grows. And eventually, it becomes invisible, just infrastructure that works.
Kubernetes is entering that invisible phase, and that's exactly what platform teams need. A stable foundation you can build on, a commodity layer that just works, a boring infrastructure that lets you focus on developer experience instead of container orchestration.
The irony is that achieving boring infrastructure is incredibly hard. It takes a decade of innovation, countless contributions, massive adoption, and eventually consensus on patterns and practices.
Kubernetes has earned its boring status. 10 years of development, millions of clusters in production, a massive ecosystem of tools and vendors. The hard work is done. Now we build on top of it.
Which brings us to our final episode. We've covered agentic AI transforming operations, platform engineering going mainstream, developer experience metrics beyond DORA, and now Kubernetes entering its boring era. In episode 5, we synthesize everything into concrete predictions for platform engineering in 2026.
What should you actually expect? What should you invest in? What should you ignore? That's the capstone of our Look Forward series.
The fundamentals remain constant. Boring infrastructure is mature infrastructure, and mature infrastructure is the foundation for exceptional developer experience.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.